In this short video, we will discuss how the interactions between water molecules account for the unique properties of water, and how aqueous solutions form. We will also explain the difference between homogeneous aqueous systems and heterogeneous aqueous systems. The following topics will be discussed in more detail: solutions, electrolytes and nonelectrolytes, hydrates, suspensions, colloids, and emulsions. Recall that water is a simple molecule, consisting of 3 atoms, where the oxygen atom forms a covalent bond with each of the hydrogen atoms. Oxygen has a greater electronegativity than hydrogen, so the covalent bonds are highly polar since oxygen will attract the electrons of covalent bond more than hydrogen. The bent shape of the water molecule determines the net polarity of the molecule. The oxygen end of the molecule is slightly negative, and the hydrogen end is slightly positive. Polar molecules usually attract one another. In water, this attraction results in hydrogen bonding. Many properties of water result from hydrogen bonding. Water has a high surface tension, low vapor pressure, and high boiling point. In a water droplet, the spherical shape is due to its tendency to minimize its surface area. Essentially, the water molecules at the surface pull inwards, creating a tension that holds the droplet together. This is surface tension, which is defined as the inward force that makes the liquid surface area smaller. Water molecules at the surface of a water drop cannot form hydrogen bonds with molecules in the air. Therefore, molecules are pulled into the body of the liquid to form spherical drops. A surfactant is a substance that interferes with the hydrogen bonding in water, thereby reducing surface tension. Example: soaps and detergents are surfactants. Adding a detergent to water breaks the hydrogen bonds. The water molecules spread out, as shown in the picture above, when a droplet of soap is added to pepper floating at the water surface. Ice, the solid state of water, has also some unique properties. As water begins to cool, it behaves at first as a typical liquid. It contracts slightly, and its density gradually increases. Below 4 degrees Celsius, water no longer behaves like a typical fluid. The density of liquid water starts to decrease. Note that when ice starts to form at the surface of a pond, it does not sink. Water is one of the few solids that float in their own liquid. Why is the ice less dense than liquid water? In liquid water, hydrogen bonds constantly break and reform. In solid ice, hydrogen bonds are stable and hold molecules further apart, so the density of ice is lower than liquid water. The hexagonal symmetry of a snowflake reflects the structure of the ice crystal. Water dissolves many of the substances with which it comes in contact. An aqueous solution is water that contains dissolved substances. Solutions are homogeneous and stable mixtures. When you mix salt and water, you obtain a salt-water solution. Salt is the solute, which are the dissolved particles in a solution. Water is the solvent, which is the dissolving material in a solution. Solvation is the process by which ions of an ionic solid become surrounded by solvent molecules. Water molecules are in constant motion, because they have kinetic energy. When a crystal of sodium chloride is placed in water, the water molecules collide with the sodium chloride crystal. The polar water solvent molecules attract the solute ions. Let's have a look how the solvation of an ionic solid in water works. When an ionic solid like sodium chloride dissolves, the ions become solvated, or surrounded by the solvent molecules. As a chloride ion breaks away from the crystal, it's surrounded by the positively charged ends of the polar water molecules. As a sodium ion breaks away from the crystal, it's surrounded by the negatively charged ends of the polar water molecules. A water molecule has a partially charged negative end, the oxygen atom, and a partially charged positive end, which are the hydrogen atoms. That's why water will tend to dissolve substances whose particles it can solvate, like ionic compounds and polar covalent compounds. Remember the like dissolves like rule, which states that polar solvents dissolve ionic compounds and polar compounds, and nonpolar solvents dissolve nonpolar compounds. Example: oil. which is a nonpolar compound, does not mix with the polar compound water. An electrolyte is a compound that conducts an electric current when it is in an aqueous solution, or in the molten state. Conduction of an electric current requires ions that are mobile. All ionic compounds are electrolytes, even if they don't dissolve in water. Barium sulfate is an ionic compound that does not dissolve in water, so it cannot conduct an electric current in water. However, barium sulfate can conduct an electric current if melted, and for this reason, barium sulfate is an electrolyte. A nonelectrolyte is a compound that does not conduct an electric current, in either an aqueous solution or the molten state. Many molecular compounds are nonelectrolytes, because they are not made up of ions. Some polar molecules become electrolytes when they dissolve in water. A good example is ammonia. An ammonia solution conducts electric current, because ammonium and hydroxide ions form when dissolved. Conduction of an electric current requires ions that are mobile. When two electrodes are connected to a battery and a light bulb, and they are dipped into the solution causing the light bulb to glow brightly, it indicates that the solution is a strong electrolyte. A strong electrolyte is a substance that nearly completely dissociates into ions when dissolved in water. If the light bulb does not glow at all, we are dealing with a non-electrolyte. A non-electrolyte is a compound that does not conduct an electric current, because it does not dissociate in water. Glucose is an example of a non-electrolyte. A weak electrolyte is a substance that only partially dissociates into ions when dissolved in water. Mercury 2 chloride only partially dissociates in water. There will be some mercury and chloride ions, but there will be some non-dissociated molecules as well. When blue crystals of copper 2 sulfate pentahydrate are heated, water vapor escapes, and white anhydrous copper sulfate is formed. Water molecules are a part of the crystal structure of this hydrate. The copper 2 sulfate pentahydrate crystals are dry to the touch. A hydrate is defined as a compound that contains water of hydration. Water of hydration is water molecules contained in a crystal. In the chemical formula, a dot is used to connect the formula unit, and the number of H2O molecules per formula unit. Look at the chemical reaction that occurs when heating a sample of the blue hydrate copper 2 sulfate pentahydrate. If you read the reaction from left to right, you notice how the hydrate loses its water of hydration when heated to form the anhydrous copper sulfate. If you read the equation from the right to the left, you see how copper 2 sulfate pentahydrate is formed again when water is added to the anhydrous copper sulfate. An anhydrous substance is a substance that does not contain water. Note that the forces holding the water molecules in hydrates are not very strong, so the water is easily lost and regained. The formula at the bottom can be used to determine the percent, by mass, of water in the hydrate. Hydrates usually have a measurable vapor pressure, because the water molecules in hydrates are held by weak forces. An efflorescent hydrate is a substance that loses its water of hydration, because the hydrate has a vapor pressure that is higher than the pressure of water vapor in the air. Hydrates that have a low vapor pressure can remove water from moist air. These are called hygroscopic hydrates. An example of a hygroscopic hydrate is calcium chloride monohydrate. This compound takes up a second molecule of water from moist air, as shown in this chemical equation. Calcium chloride monohydrate is used as a desiccant in the laboratory. A desiccant is a substance to absorb moisture from the air. A solid desiccant such as calcium sulfate can be added to a liquid solvent like ethanol to keep it dry. The calcium sulfate doesn't dissolve much in the solvent. When a desiccant has absorbed all the water it can hold, it can be returned to the anhydrous state by heating. A deliquescent compound is a substance that removes enough water from the air to form a solution. Example: sodium hydroxide. Therefore, containers of sodium hydroxide and other deliquescent chemicals should always be tightly sealed. In this section, heterogeneous aqueous systems will be discussed. If you shake a container containing chalk powder and water, the particles settle out if you stop shaking. This is an example of a suspension, it is a mixture from which particles settle out upon standing. Suspensions are heterogeneous because at least two substances can be identified. The particles in a suspension are much larger than the particles in a solution. Usually the particle diameter is larger than 1000 nanometer. Consequently, the suspended particles can be removed by filtration, because they cannot pass through the filter paper. In contrast, the small solute particles in a solution will pass through the filter paper. Colloids are heterogeneous mixture containing particles between 1 and 1000 nanometer. The particles are spread throughout the dispersion medium, aka solvent, which can be solid, liquid, or gas. Many colloids look cloudy or milky. Colloid particles are small enough to pass through filter paper, and Brownian motion keeps the particles suspended. Brownian motion refers to the chaotic movement of colloidal particles. Colloidal particles also tend to stay suspended, because they become charged, by absorbing ions from the dispersing medium. A colloidal system can be destroyed, or coagulated, by adding electrolytes. A beam of light is visible as it passes through a colloid, or a suspension. This is called the Tyndall effect, which is the scattering of visible light by particles that are larger than 1 nanometer. An emulsion is defined as a colloid dispersion of a liquid in another liquid. Mayonnaise is an example of an emulsion. It is a heterogeneous mixture of oil and vinegar. The mixture of oil and vinegar would quickly separate without the presence of egg yolk, which is the emulsifying agent. This table summarizes the properties of solutions, colloids, and suspensions. Let's have a look at the particles. The solvated particles in a solution can be ions, atoms, and small molecules with a size less than 1 nanometer. In a colloid, the particles are large molecules or particles with a size between 1 and 1000 nanometers. Suspended particles are very large or aggregates with a size of 1000 nanometer or larger. Solutions do not scatter light. Colloids and suspension exhibit the Tyndall effect. Solutions and colloids are stable and don't settle. Suspensions are unstable and a sediment forms. The solute particles in a solution or the dispersed particles in a colloid are not retained by a paper filter. Suspended particles are large enough to be retained on a filter. Solutions are homogeneous mixtures, while colloids and suspensions are heterogeneous.